Hello everyone, in this video we are going to discuss JEE Main 2026 PYQs from the chapter Relations and Functions, and in this video I will be discussing all shifts, January and April shift, because there are only 10 questions. And before moving to every question, please pause this video and try this out, and also set a timer of 2 to 3 minutes, because this is such an exam where for large number of questions very short duration is given. 3 hours is not so sufficient to solve entire 75 questions. So that's why for every question please set a timer of 2 to 3 minutes and try to solve faster with 100% accuracy. So let us move on to first question. First question says, consider the relation R on the set -2, -1, 0, 1, 2 defined by A, B belongs to R if and only if 1 plus AP is greater than 0. Then among these statements, they are asking which of these two statements are true, whether 1 or 2 or both or neither. So let us look into this question. So if you see, they have given an inequality 1 plus AB is greater than 0, which implies AB should be greater than -1. Okay, now we have given this set from -2 to 2. So now let us see. AB is greater than -1. AB is greater than -1, and the set given is -2, -1, 0, 1, 2. First statement is number of elements. Second statement is whether R is equivalence or not. So let us do second statement first. Always start with easier one, then go with harder one, because this is easier one. We can use just 3 tests to check whether R is equivalence or not. First test is reflexive. What does reflexive say? A, should belong to R. If you see A square is greater than 1 is always true. So that's why this relation is reflexive. Now if you see symmetry, if AB is greater than -1, which implies BA is also greater than -1, which is 100% correct, because multiplication follows commutative rule. Now if you see transitive, if AB is greater than -1 and BC is greater than -1, this implies AC should be greater than -1. This is not always true, because if we take an example, let's say A is -2, B is 1, and let's say C is 0. Let us take B as 0 and C as 1. B as 0 and C as 1. B as 1. Now if you see A and C, B as 0. Now if you see 0 is greater than -1, and here also 0 is greater than -1, but if you see A into C, it is going to be -2, and -2 is definitely not greater than -1. So that's why this is not transitive, hence statement 2 is wrong. So this implies B can't be the answer and C can't be the answer. So we have only two options, A or D. Now let us see first statement, number of elements in R. Now we know that AB is greater than -1 and the elements are from -2 to +2, right? Yes, -2 to +2. Now if I take A as -2, let's say, then what numbers B can satisfy? Let us see. Now let us have A, B. Now let us get a table for A and B. Now if I have A as -2, then B can be -2, B can be -2, -1, 0, but it can't be 1 or 2, because this has to be greater than -1. So that's why here you will get 3 elements. Now if you take -1, here you will get -2, -1, 0. Here you will also get 3 elements. Now if you take 0, you can take all elements from -2 to +2, which include which is equal to 5 elements, right? So 5 elements because 0 is greater than -1. Now if we take 1 over here, a as 1, then you can take 0, 1 and 2, right? So here we'll have 3 elements, and if I take 2 over here also you'll get 0, 1 and 2. So finally here also you'll get 3 elements. Now if you add all these 5 list, then you'll find out that the sum is equal to 17. So yes, first statement is correct, that number of elements in R is 17. So that's option A is correct and option D is wrong. Okay, now let us move on to next question. Now the second question says that let R be a relation defined on the set 1, 2, 3, 4 into the same set by R is equal to A, B, C, D is equal to such that 2A plus 3B is equal to 3C plus 4D. Then they are asking number of elements in R. Now if you see the given equation that 2A plus 3B is equal to 3C plus 4D, one thing is clear that we can keep 3 multiple in one side and 2 multiple in other side. So this implies 3 times B minus C is equal to 4D minus 2A, and this can be rewritten as 2 times 2D minus A. So this is how this can be rewritten as. Now let me copy this equation. 3 times BC is equal to this thing. Okay, and let me remove this one. Yeah, and the set given is 1, 2, 3, 4. 1, 2, 3 and 4, and they're asking number of elements, right? So if you see here you have 3 times B minus C, and here you have 2 times 2D minus A. So one thing is clear that this has to be a multiple of 2 and this has to be a multiple of 3. Okay, this has to be a multiple of 2 and this has to be a multiple of 3. So what we can do is that we have to find difference of such two numbers which are actually multiples of 2. Now if you see 4 minus 2 and 3 minus 1 will satisfy, 4, 2 will satisfy, and the reverse will also satisfy, which is 2, 4, and 3, 1 will also satisfy and the reverse will also satisfy. And not only that, even if you take B equal to C also it will satisfy. Like if you take 4, 4, 3, 3, 2, 2 and 1, 1, then also it will satisfy because 0 is also a multiple of 2. Now if you see in the LHS, the value that you will get by placing B as 4 and C as 2 will be 6 because 3 into 2 is 6. Now we have to make 2D minus A as 6. Now one way to make 2D minus A as 6 is that you can place D as 4 and A as 2, then you will get one count, like one element inside the R. Also if you keep 3 and 3 also you will get 2D minus A as 3. So this also can be considered. And apart from that, if you see any other thing is not possible, like if you consider D as 2, A as also 2, not possible, D as 1, A as 1, not possible. So only these two are the possible options for 4, 2. Now if you see 2, 4 where B is 2 and C is 4, if you see this will give minus 6, but here you will not get minus 3 because 2 is positive, so 2D minus A should be negative, and that is not possible. So here we will not have any element, and here also we will have something like 4, 2 and 3, 3 because the same 6 will appear over here. So here also we will get 4, 2 and 3, 3. And for these for these 4 cases, either you can have D as 2 and A as 4, or you can have D as 1 and A as 2. So that's why here you are going to get 2 elements, here you are going to get 2 elements, and this is multiplied by, okay, this is 2 elements, and here you are going to get 2 elements, but this is multiplied by 4 because there are 4 cases. So here you will get 8. So finally the answer for this question is 12. 8 plus 2 plus 2. So the answer for this question is 12. Now let us move on to this third question. Now third question says, consider two sets A equal to x belongs to z such that mod x minus 3 is less than equal to 1 and b is equal to x belongs to r minus 1 comma 2 such that x minus 2 x minus 4 divided by x minus 1 into log ln x minus 2 mod is equal to 0, and they are asking the number of onto functions from A to B. Let us see how we can solve this. Now if you see, there are two sets A, and basically here you have to find out the number of elements in A and B so that we can find out number of onto functions from A to B. Now if you see, the equation given, the inequality given in A is something like mod x minus 3 minus 3, and this should be less than equal to 1 if I am not wrong. Now if you take out mod on both sides, if you remove this mod in a left hand side, then you will get minus 1 less than equal to x minus 3 mod minus 3, and this should be less than equal to 1. Sorry, minus 1 greater than equal to x minus 3 mod minus 3 less than equal to 1. And if you take 3 on both of these sides, then you will get 3 minus 1 is 2, and this should be greater than equal to mod of x minus 3 and mod of x minus 3, and this should be less than equal to 4. Now if you plot this graph mod of x minus 3, then you will get something like this. Right, let me draw a line. So if this is the graph, x-axis, y-axis, okay, x-axis, y-axis, then your mod x minus 3 is going to be something like this, okay, where this will be 3 and this will also be 3, okay. And if you see, the range is from 2 to 4, so this will be 4 and this will be 2, and for the value of 2 you are going to get this one also as 2, right, okay. Now this one you will get the value as 2, right, because we are minusing 1, you will also minus here by 1, and for 3 you will get 3 only, okay, for 3 you will get 3, and also sorry, for 3 you will not get 3, for 3 you will get 0 here, and also you will get one more value which is 4. And please note that this graph is not to scale, so here and there might be some fluctuation. So for 3 you will get 4, and for 4 you will get 5, right, because 5 minus 3 is 2. Oh sorry, wait, 2. For 3 you will get 0, for 2 you will get 1, I'm sorry here. So for 2 you will get 1, and for 1 you will get 2, right. Now if we, so sorry, for x equal to 1 you will get y as 2, right. So for x equal to 1 we will get y as 2, and for x equal to 0 you will get 3, and for x equal to 5 also we will get 1, right, because oh sorry, so if x equal to 5 also you will get mod of x minus 3 as 2, right. So this will be 5, and for this one this will be 4, okay. So this will be 4 and this will be 6, okay. Yeah, this will be 6 and this will be 7, right. This will be 7 minus 3 is 4, okay. So now they are saying that this inequality, this mod is from 2 to 4, so if you take everything from 2 to 4, then this part is considered, and here we will get minus also as well, right. Here we will get minus 1, right, minus 1 will also come, and if we consider this part, and then if we consider this part as well, consider these two parts, then you will see that x belongs to minus 1 to 1 union 5 to 7. Okay, 5 to 7. Now if you see x belongs to integers, they are given here. So we will come to know that mod a, number of elements in a, this can be also written as mod a, and this is equal to minus 1 2 3 4 5 6. So mod a turns out to be 6. Now let us talk about the set B. They have given an equation and they are saying that we must not consider x as 1 comma 2 or else it will be undefined, right? If you place 1 as here, you will get divided by 0. If you place 2 over here, you will get ln of 0, and that is also not defined. So that's why let us look into that equation. So we'll get, now one thing is very clear directly, that B can be only 4 or 3, right? Because if you place 4 over here, you will get 0, and this equation will not be undefined. And if you take 3, then you will get ln 3 minus 2 1, and that will also be 0. So let me write again, x minus 2 b x minus 2 x minus 4 by x minus 1 times ln mod x minus 2 should be equal to 0. Now to keep this 0, you should make this as 0. Now to make this as 0, only one option possible is x is equal to 4, because if you keep x equal to 2, then this will be undefined. If you keep, okay, so and if you keep x equal to 1, this will be undefined. So for this to be 0, only one option is x equal to 4, and to keep this 0, mod x minus 2 should be 1. Okay, if we found this as 0, then mod of x minus 2 should be 1, which implies x minus 2 should be plus minus 1, and this implies x should be 1 comma 3, and 1 is not possible and 3 is possible, so that's why x should be equal to 3. So if you see, number of elements in B is equal to 2, because only two solutions are possible. Now if we consider number of onto functions from A to B, we know that mod A is equal to mod A is equal to 6, and mod B is equal to 2. Mod B is equal to 2. So since the question is about number of onto functions, then one thing is clear, that 6 has to be divided into two distinct groups. 6 has to be divided into two distinct groups, right? Into two distinct groups. Okay, two distinct groups. So only three options would be possible, like if you divide 6 as 5 1, 6 as 5 1, and 6 as 4 2, and 6 as 3 3. Now the reverse is also possible, 2 4 and 1 5, that will multiply by 2 when we are evaluating. And when it comes to distribution into groups, then there is one common result, that number of such distribution possible would be 6 factorial for first case, 6 factorial by 5 factorial into 1 factorial, right? Something like this. Okay, 6 factorial by 5 factorial, 1 factorial, and since the reverse is also possible, so here you will get 2, and finally you will get this answer as 12. Now here if you do the same thing, you will get 6 factorial by 4 factorial, 2 factorial into 2, and 6 factorial by 4 factorial is 30, and 30 by 2 into 2 is again 30. And for the last case, if you take 6 factorial by 3 factorial and one more 3 factorial, here into 2 is not required, because reverse will also be same thing. And 6 factorial by 3 factorial will be 6 into 5 into 4 120, and 120 by 6 will be 20. So the final answer is 30 plus 20 plus 12, which is nothing but 62. So number of onto functions from A to B is 62. So the final answer for this question is 62. 62 is there? Yes, 62 is there. Let us move on to next question. Next question says let A is equal to 0, 1, 2 come up to 9. Let R be a relation on A defined by x comma y belongs to R if and only if mod of x minus y is a multiple of 3. And they have given two statements. Statement 1, n of R is 36, and statement 2, whether R is equivalence or not. This is like first question only, as they are asking number of elements and equivalence relation, and they have given 4 options to judge whether which of the statements are true or false, right? So now let us look at second statement, that is easier to deal with. Now first thing is whether 2 is equivalence, whether R is equivalence or not. So for that, if we take x minus y mod as 3n, because this is multiple of 3. Now for reflexivity, reflexive, if we take x minus x, then we'll get 0, and 0 is definitely multiple of 3, so R is reflexive. If we take symmetry, then mod of x minus y is equal to mod of y minus x, and this should be a multiple of 3n because mod does not change the value, so even symmetry satisfies. Now if you see transitive, okay, mod x minus y should be 3n, and if mod x minus y is 3n and mod y minus z is 3, let's say 3m, this implies that now if you remove mod from these two equations, you will get like x minus y is equal to plus minus 3n, and y minus z is equal to plus minus 3m. Okay, 3m, and if you add these two equations, you will get that x minus z is equal to plus minus 3 times n plus m. Okay, n plus m, and if you take mod on both sides, you will get mod of x minus z is equal to 3 times m plus n, and definitely it also satisfies transitive, so hence statement 2 is correct, which implies option A is wrong and option C is wrong, so we are left with B and D. Now let us see among these which of them is correct. If you look at first statement, they are asking number of elements, so the set A is from 0 to 9, and they are asking to find out something like this, like x minus y is a multiple of 3. Okay, now if you observe one thing, that from 0 to 9, 0, 3, 6 and 9, they are in the form of 3n, right? They are multiples of 3 anyway. And if you see 1, 4, 7, they are in the form of 3n plus 1. And if you see 2, 5 and 8, they are in the form of 3n plus 2, right? So what we can conclude from here is that if you take x as 9, now if I make a table of x and y, now if you take x as 9, then you can take 0 to 9, 0, 3, 6 and 9, and hence here you will get 4 cases, right? And for the first three numbers you can actually take the reverse as well. 9 minus 0, 0 minus 9, 9 minus 3, 3 minus 9, 9 minus 6 and 6 minus 9. So here what will happen is that we will have to count those case as well. So you will get something like, here you will get 6 and here you will get 1. Finally you get 7 over here. Okay, now if we take x as 8, then the possible case would be 1, 4 and sorry, if you take 8, then 2, 5, 8 are possible. 2, 5, 8 are possible, and this can be, and for these two numbers the other reverse case is also possible, like 8, 2 minus 8 and 5 minus 8. So here you will get 4 and here you will get 1, so this would be 5. And if you take x as 7, then you will get 1, 4, 7. Similarly here also you will get 4, here you will get 1, and finally this will also be 5. The one with x equal to 7. Now if you take x as 6, let me write in next page. Okay, now if I consider x and y over here, and if I take x as 6, if I take x as 6, then the possible cases are 0 and 3. 0, 3 and 6, you must not take 9 because we have counted here. So here you will have 0, 3, 6, and here also 4 case will come, here 1 case will come, so finally you will get here 5. And if you take x as 5, then the possible cases are 2 and 5, 2 and 5. Here you will get 2 cases, here you will get 1 case, so here you will get 3. And if you take x as 4, then here you will get 1 and 4, here you will get 2 and here you will get 1, so finally you will get, finally you will get here also 3. Okay, now if you take x as 3, now if you take x as 3, now if you take x as 3, then the possible values of y are 0 and 3, and here you will get 2 cases, right? 3 minus 0 and 0 minus 3, and here you will get 1 case, so this will also be 3. And if you take 2 over here, then only 1 case is 2, here you will get 1. If you take 1, 1, here also 1. If you take 0, 0, here also 1. So finally we have listed all cases. Now let us see how many elements are there. Now if you see in first case we have 7, 5, 5. So finally we have 7 plus 5 plus 5. Okay, then we have here 5 plus 3 plus 3, 5 plus 3 times 3. Okay, let me write 5 into 3 over here. Okay, 7 plus 5 into 3 plus 3 times 3, and after this what we have, then we have 3 times 1, 3 times 1. Okay, wait. Yeah, 3 times 1. Now if you calculate this, you will get 7 plus 15 plus 9, 7 plus 15 plus 9 plus 3, so we'll get 22 plus 12, and this is equal to 34. Now if you see first statement, they said there are 36 elements, but we came to know that there are only 34 elements, so hence first statement is false, only statement 2 is true. Okay, so this concludes that option D is correct and option B is wrong. Okay, now let us move on to next question. How many are left? 1, 2, 3, 4, 5, 5 and 6. Okay, come on, let us do the fifth question. Fifth question says that A is equal to minus 2 comma minus 1 comma 0 1 2 3 4. Let R be a relation on A defined by x or y if and only if 2x plus y is less than or equal to L be number of elements in R, M be minimum number of elements required to be added in R to make it reflexive, and N is the same minimum number of elements to make it symmetric, and they are asking L plus M plus N. Now let us see how we can do this. Okay, now the set given is from minus 2 to 4. Okay, set is from minus 2 to 4, and the inequality is 2x plus y is less than or equal to 2. Now if I keep this 2x in the right hand side, then we'll get y is less than or equal to 2 minus 2x, so this can be written as 1 minus x as well. Okay, now if I take y as 4, then possible values of x are minus 2 because you'll get 6 over here. Okay, and minus 1 is possible because you'll get 4 over here. That's it, only these two cases are possible, so you'll get 2 over here. Here also you can make a table. Okay, now let me write this in reverse so that we will not make any mistakes. This implies 2 times 1 minus x is greater than or equal to y, and if I make a table of x and y, make a table of x and y. Now if I take as y as 4, then possible values of x are minus 2 and minus 1, because here you will get 6 and here you will get 4. So number of elements are 2 from this point. Now if you take y as 3, then possible values are minus 2 and minus 1. So here also 6, here also 4, here also I will get 2. Okay, now if I take y as either 2 or 1, actually you could have merged these 3 and 4 into one case only because we are getting same result, so that we can write 2 into 2 4. But now let me merge these 2 and 1 here. Now if you merge these, then 3 cases are possible. Minus 2 because you'll get 6 over here, minus 1 because 4 will come here, and 0 because 2 will come here, and this will yield a result of 3 into 2, which is 6. Now if you take y as 0 or minus 1, 0 comma minus 1, and possible cases are minus 2 because you'll get 6, minus 1 because you'll get 4, 0 because you'll get 2, and if you place my 1, you will get 0 over here because equality is also there. So finally here you will get 8 cases, right? 4 into 2 8. Now if I do this in next page, right? Okay, x, y, and if I take now y as, let's say, if I take y as 2, right, minus 2 because we have taken till minus 1. If I take y as minus 2, then possible cases are minus 2 because 6 will come, minus 1 because 4 will come, 0 because 2 will come. Okay, you can take 1 also because you'll get 0, and finally if you take 2, you will get minus 2, right? So here there are 5 possible cases. So the value of L, because L is number of elements in R, so the value of L will be 2 plus 2, which is 4, 4 plus 6 plus 8 plus 5, 4 plus 6 plus 8 plus 5, which turns out to be 23. Okay, so this is the value of L. Okay, now if you see for M, they are saying minimum number of elements required to be added to make R reflexive, right? And these cases, the L and M and R are actually individuals, right? You cannot make R also symmetric and reflexive, we have to consider separate cases. Okay, so for that what we can do is that we have to look for those elements where reflexive is not appearing. Now if you see 0 0 is appearing, right? You can see over here 0 0 is appearing, 0 0 is appearing. Let me change the color. 0 0 is appearing, so this is one reflexive case, and second reflexive case is -1 here also it is coming, and third reflexive case is -2 and -2. So if you see, there are three reflexive elements that already exist in R. So the minimum elements to be added to make it reflexive comes from -1, 1, and also -1 already is there, so -1 is not required. So we need reflexive from 1, 2, 3 and 4. So that's why M turns out to be 4. Okay, now let us see N. Now for N, you have to see which elements are existing in symmetry, so that for other elements we can write symmetric one. Now let us see how that is a bit tedious task. Now if you see, for x equal to -2 and 4, there is no symmetric anywhere, right? If I merge these two cases in one place, you'll understand better. Okay, let me merge these two cases. Okay, let me wipe this off. Okay, and let me bring the one more case as well, which is this one. Okay, and if I bring it over here, okay, let me write again. So for last case we have something like -2, -1, 0, 1, 2, right? If I take y as -2, and here you will get 5, and this will give you 23. Now if you see symmetric elements, minimum elements required. Now if you see for -2 and 4, there is no symmetric element anywhere, so we need to add 4 and -2. This is one element. And if you see -1 4, 4 -1 is not there, 4 -1 is not there. Now if you see -2 3, 3 -2 is not there, right? Now if you see -1 3, and 3 -1 is also not there, 3 -1 is also not there. Now if you see -2 2, but 2 -2 is there, where -2 2 and 2 -2 is here, -1 1 and 1 -1 is there, and 0 1 1 0 is there. Okay, let me take it one by one. For -2 2, you have 2 and -2, and for -1 2, do you have 2 -1? No, we don't have 2 -1, so that should also be counted. So 2 -1. Okay, 2 -1 is not there. Now if you take 0 2, 2 0 is there? No, 2 0 is not there. We have to count that one as well. So 2 0 is also not there. 2 0. Okay, then do we have -2 -1? Wait, -2 1 is there? Do we have 1 2? No, we do not have 1 2 as well. We do not have 1 2 as well. Yeah, okay. Come on now. Fifth math. Y(2) we have seen that -2 and 0 there is symmetric elements, and -1 there is no symmetric elements, so we have added. Now if you see for 1 and for 1 minus for -2 1 we have 1 -2, right? -2 1 we have 1 -2, and for -1 and 1 we have 1 and -1, right? And for x is 0 comma 1 we also have 1 comma 0, right? Like, let me show you the number of the elements where symmetry is not there. Okay, let me erase this one. Now let me write the entire relation so that you'll understand better. Okay, so we have -2 comma 4, then we have -1 comma 4. Okay, then we have -2 comma 3, -2 comma 3, then we have -1 comma 3. Writing all 23 is not possible, so let's try to understand what I'm saying. Okay, come on. Now if you see, for -2 and 4 you do not have symmetric one, so you have to add 4 -2. For -1 4 you do not have, so we need to add 4 -1. And for -2 3 also you do not have, so we must add 3 -2. For -1 3 also you do not have, so we must add 3 -1. And for -2 2 we have -2 2 we have 2 -2. And for -1 2 we have 2 1. Do we have 2 1? For -1 2 we have 2 -1. No, we do not have, so we must add, so it's 2 -1. And for -1 1 do we have 1 -1? Yes. For 0 2 do we have 2 0? No, we must add this one. Okay, and if we take y as 1, if -2 1 is there, then 1 -2 is there. Yes. -1 1, 1 -1 is there. Yes. 0 1, 1 0 is there. Yes. Now if you see -2 0, 0 -2 is there. Yes. -1 0, 0 -1 is there. 0 -1, yes, so not required. And if you take 1 0, 0 1 is there. Yes. And if you take with -1 -2 -1, -1 -2 is there. Yes. Like, if you see all combinations you will come to know that everything is there. So that's why these 6 elements are the minimum number of elements required to make it symmetric. So that's why n is equal to 6. Okay, for remaining cases you can check it by yourself, it will not be that difficult one. So here you will get 6, here you will get 4, here you will get 2, here you will get 0, here you will get -2. Okay, so we come to know that L is equal to 23, L is equal to 23, M is equal to 6, M is equal to 4, and N is equal to 6. So summation of this is, okay, or L plus M plus N is equal to 33. So the final answer for this question is 33. Okay, and let us move on to next question. Next question says number of elements in this relation is, and they are given 4 options. So let us see how we can do this. Okay, now if you see the inequality says 4x square plus y square is less than 52. This implies that y square should be less than 4 times 13 minus x square, or if I write this in reverse, 4 times 13 minus x square should be greater than y square, and the values of x and y belongs to integers. Okay, now if I take y square as, let's say, 0, then the possible values of x square are 0 plus minus 1, because here you will get 52 if you put x as 0. If you put x as plus minus 1, you will get 48, and if you put plus minus 2, 13 minus 4, 9, 9 into 4, 36 possible. If you put plus minus 3, 13 minus 9, 4, 4, 4 is 16, and if you put plus minus 4, you will get negative. So here the number of cases are 7, and if you put y as plus minus 1, you can have 0 plus minus 1 because 48 will appear, plus minus 2 because 36 will appear, and plus minus 3 because 16 will appear. Okay, and if you take plus minus 4, then we will get minus 12. That is not possible, so we have to stop here only. And if you see from this side, 8 cases are, sorry, 7 cases are possible, and into 2 will give you 14. Okay, into 2 will give you 14. Okay, and if you take y square as plus minus 2, then the possible cases are 0, plus minus 1, plus minus 2, and plus minus 3 again, because if you place x as plus minus 3, you will get 16, and this will be 4 only, so this is also possible. You will get 14 over here. And if you take y as plus minus 3, you will get 9, and here also you will get all of these elements, so here also you will get 14. And if you continue further, okay, now if you continue further, if you take y square as plus minus 4, if you take y square as plus minus 4, then here you will get 16, and since plus minus 3 is also giving you 16, in the next case you cannot take plus minus 3, so we have to take 0, plus minus 1, plus minus 2, so here you will get 5 into 2, 10. Now if you take y square as plus minus 5, here you will get 0, plus minus 1, plus minus 2, because plus minus 2 will give you 36, and this is 25. Here also you will get 10, and if you take plus minus 6, here you will get 36, so you cannot take plus minus 2, so you are left with 0, plus minus 1. Here you will get 3 into 2, 6, and if you take plus minus 7, you will get 49. Here only 0 is possible, because plus minus 1 will give you 48, and that is not possible, so here you have 2. So finally you are left with the sum as 7 plus, okay, so you write in next page, 7 plus 14 times 3, right, 14 times 3, and then you have 2 times 10, okay, 2 times 10, and then you have 1 6 and 1 2. Okay, now if you add this, you will get 7 plus 42 plus 28, and if you add this, you will get 77. So the final answer for this question is 77. Now how many questions are left? 1 2 3 4 more questions to go. Now here is the 6th question. Let the relation R on the set M be given by R is equal to x comma y such that 4y is equal to 5x minus 3xy belongs to M, and the minimum number of elements required to be added in R to make it symmetric is equal to. Okay, now let us construct the relation. Now the set is from 1 to 16. The set is from 1 to 16. 1 1 to 16, and the equation given is 4y is equal to 5x minus 3. 4y is equal to 5x minus 3. Okay, now let me write this in reverse. 5x minus 3 is equal to 4y. Okay, now if you keep x's, basically you have to notice that 4y multiple of 4 should be in the form of multiple of 5 minus 3. If you consider multiples of 5, you will get 5, 10, 15. The maximum multiple here is 80, right? We are 16 into 5, right? Yeah, 5, 10, 15, 20, 25, 30, etc, etc, etc. Now if you see, 15 is one such element because 15 minus 3 is 12, and that is the form of 5x minus 3 is equal to 4y. So here if you take x as 3, then your y will also be 3, and similarly if you take x as 7, then 35 minus 3 will be 32, and this will be in the form of 8. So if you see here, you have to add a plus 4, here you have to add a plus 5. So if you add one more plus 4, you get 11. Here if you add one more 5, you will get 13, right? 55 minus 3 is 52, that is 13 into 4. If you add one more 4, you will get 15, right? 15 will appear over here. And if you add one more 5, 18 will appear, but 18 is not there, so we cannot consider that one. So we are only left with these three elements, which is 3, 3, 7, 8, and 11, 13. And they are asking number of elements required to make it symmetry, and symmetry is required from these two cases only, because this is reflexive, which is automatically symmetric. So that's why the final answer is 2. Now let us move on to 7th question. Now in the 7th question they have given two inequalities. Now let us see how we can do this. A is equal to x square minus 10 mod less than equal to 6. A is equal to mod of x square minus 10 less than equal to 6. Okay, less than equal to 6, and if you open the mod you will get minus 6 less than equal to x square minus 10 less than equal to 6, minus 6 greater than equal to x square minus 10 less than equal to 6. Now if you take this 10 on this side and that side, you will get 4 less greater than equal to x square less than equal to 16. Now if you plot this graph, okay, if you plot this graph, here you will have 4 and here you will have 16, and for 4 you will get minus 2, and for 16 you will get minus 4. Even plus 2 plus 4 is possible, plus 2 plus 4 is also possible. So finally we get to know that x should belong to minus 4 to minus 2 and union with 2 and 4. So this implies A should be this one. Okay, A should be this one. A should be equal to this one. Okay, now let us calculate for B as well. Now if we consider B, then B is given as x minus 2 mod is greater than 1, right? Now if we construct a graph for this, then we will see that mod of x minus 2 is like this. Okay, where this is 2 and this is also 2, and here you have 1, and for that one you will get x as either 3 or 1, right? Either 3 or 1, and they are saying that mod of x minus 2 should be greater than 1, so we have to consider this one, right? If I represent in the other color, then it is this one. Okay, this part. So it is clear that x should belong to minus infinity to 1 union 3 to infinity. So B should be this one. Okay, B should be minus infinity to minus 1, right? Sorry, plus 1 followed by union with 3 to infinity. So if I plug this in number line, we will get something like this. We have minus 4, minus 2, 1, then 2, then 3. Now let us plot A with green, okay, with a line. Minus 4 to minus 2. Oh sorry, this has to be green, right? Green. Minus 4 to minus 2, and here we have 4 as well, right? So this should be from 2 to 4. Okay, and your B should be, you represent this in blue color. This should be from minus infinity to 1 and 3 to infinity. Okay, so if I represent with these dotted lines, and it's going to be like this, this will be like this, and for the A one, this will be like this, like this, like this, and like this. Okay, so green is A and blue is B. This is A and this is B. Okay, now they have given 4 options, that A union B. Okay, let me show you. 4 options are A union B, B minus A minus B, and A intersection B. Let us evaluate one by one. Okay, come on. Okay, now A union B is something like, if you consider option A union B is like, it starts from minus infinity to 1 and from 3 to infinity. That is your A union B, right? A union B is minus infinity to 1 union 3 to infinity, but the option says 2 to infinity, right? So this is wrong. So let me calculate everything and then finally we will evaluate. So this is A option. B option says A minus B, sorry, B minus A. B minus A means like we have to remove the elements of A from B, like we have to remove this one and you have to consider the rest of the cases. So B minus A will be minus infinity to minus 4, like minus infinity to minus 4, minus infinity to minus 4 union, and union we will have minus 2 to 1 as well, right? Minus 2 to 1. Since we are removing minus 4 as well, so we should not include this minus 4 and minus 2, and then we will have 4 to infinity. So this is option B. Now if you see option C says A minus B. A minus B means from A you have to remove the elements of B. If I show this in blue, this will be in green. Okay, green. Okay, now for this I'll show in blue. Now if you have to remove elements of B from A, then this will be like this. Okay, then this indicates that A minus B is equal to minus 4 to minus 2 union 2 to 3. Okay, and finally option D says A intersection B, and that is nothing but minus 4 to minus 2 and union with 3 to 4. Okay, so this is A intersection B. Now let us evaluate the options. Now option A is saying option A is wrong. Option B I think should be correct, because minus infinity to minus 4, minus 2, 1, 4, infinity, all open, right? So I think option B is the right answer. So the final answer for this question is B. Let us move on to ninth question. Ninth question says let A is equal to 2, 3, 5, 7, 9 and R be the relation on A defined on X or Y if and only if 2x is less than or equal to 3y, L be number of elements, M be minimum elements required to make it symmetry. Now they are asking L plus M. Okay, now let me write the set. Set is 2, 3, 5, 7, 9 and the inequality is 2x less than or equal to 3y and they are asking L. Now if I place x as 9, then possible cases are, because 2 into 9 is 18, so possible cases are 2, 3, 5, that's it, right? Only these three are possible. Oh sorry, this has to be greater than, right? So 9 is possible, 7 is possible because it's 18, only these two elements are possible, so this is 2. And if we take x as 7, then 3y will be 9 and y will be 9, 7 because it's 23, 27, this is 21, then 5 means 15, this is 14, so this will be 3. And if you take x as 5, this will be 9, 7, 5, 15, this is 10, and 3 is not possible because that is 9, so this is 3 again. Now if you take x as 3, 2 into 3 6, so 9, 7, 5 and 3 is also possible, so here you will get 4. If you take 2, 9, 7, 5, 3 and 2 is also possible, so here you will get 5. So the number of elements are 2 plus 3, 5 plus 3, 8 plus 4, 12 plus 5, 17. Okay, so L is equal to 17. L is equal to 17. Now M is saying that minimum elements required to make it symmetric. Okay, now let me copy paste this. Okay, let me remove these things. Okay, now if you see here we have the cases. Now we have to see which elements are not in symmetric. Now if you see 9, 9 not required, 9, 7, 7, 9 is there, 7, 7 not required, 7, 5, 5, 7 is there, 5, 9 but we don't have 9, 5, so 9, 5 is required to be added. Okay, then 5, 5, 5, 7, 7, 5 is there, yes it is there, 5, 5 not required, 3, 9, 9, 3 required, 9, 3 required, 3, 7, 7, 3 required, 7, 3 is required, 3, 5, 5, 3 is required, yes 5, 3 is required, 3, 3 not required, 2, 9, 9, 2, yes 9, 2, 9, 2, 2, 7, 7, 2, 7, 2 is required, and 2, 5, 5, 2, 5, 2 is required, and 2, 3, 3, 2 is also required, and 2, 2 is not required. Okay, so if you see M is equal to 8, so 8 should be the minimum number of elements, and the final answer is 17. Okay, so L plus M is equal to 17 plus 8, and this should be 25. So the final answer should be 25, and option B is the right answer. Okay, now let us look into the last question. A number of relations defined on the set ABCD which are both reflexive and symmetric. Now for this question we can use the approach of matrix. If I take this something like this, okay, 1, 2, 3, 4, okay, expand this, and then if I take one more like this, 1, 2, 3, 4, yeah. Now if I take A as A, B, C, D, A, B, C, D. Now if you want to make reflexive, then all A, B, C, D should satisfy A, B, B, C, C and D, D. So this should be a compulsion. So here it should be yes, yes, yes and yes. or tick tick tick. Okay, so tick tick, or let me have yes itself. Yes, 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 yes. Now when it comes to symmetric, there is no such compulsion. If A B belongs to R, then BA should also belong to R. So when it comes to AB, this can be yes or no, right? This can also be yes or no. This can also be yes or no. This can also be yes or no, and this can also be yes or no. This also can be yes or no, right? Now if you see, these 6 elements are something where there is no such compulsion that they have to appear. If they appear, then these other 6 should also appear, which is mirroring to this diagonal, which is this one. They also have to appear, just in case if the upper part is appearing. Okay, so finally we come to know that there are 6 such cases, right? 3, 2, 1, and each of them has two choices, and if you use principle of counting, then you'll come to know that it is 2 power 6, which is nothing but 64. The final answer for this question is 64. So that's it for the chapter relations functions. Hope we will see you in the next video. Until then, take care and all the best for your JEE preparations.